Everyone, it's Coach Fred here, and today I'm going to be extending what we've been learning about logarithms and review some laws of logarithms that allow you to condense or expand expressions that deal with logarithms in different ways. So we're going to look at some ways that you can expand and condense logs. So one law says that if you have log base b of m times n, then you can expand the log and rewrite it as log base b of m plus log base b of n. And let me just show you a real example why that works. Okay, so let's pretend for a second I give you log base 2 of 8 plus log base 2 of 2. Well, if we evaluated these separately, log base 2 of 8 you know is 3, and log base 2 of 2 you know is 1, so the expression should equal 4. All right, well, let's use the law where we multiply the two expressions. So this would also could be considered log base 2 of 8 times 2, which is log base 2 of 16. Log base 2 of 16 you also know to be 4. So the law of logarithms basically says that if you have two quantities being multiplied, you can expand it using addition, or if you have two expressions being added, again, if they have the same base, you can bring them together with multiplication. And you're going to decide which one of these are easier. If you're solving an equation, then putting them together sometimes is easier. All right, let's try it again. Here's the next one. Log base b of m divided by n. So if the expression with the log is being divided, you can expand it using subtraction. So let's see how that would work. If we use the same numbers, log base 2 of 8 minus log base 2 of 2, again, we'd have 3, but in this case 3 minus 1, which gives me 2. Well, if we use the law of logarithms and brought those together, it would be log base 2 of 8 divided by 2, or log base 2 of 4, which is also 2. So you can see how that works really nicely with each other. All right, this next one kind of goes along with Coach Fred's favorite law. Remember that law I loved where it was like 3 to the x equaled 3 to the 2? And when the bases were the same, then x equaled 2. Well, we've got similar strategy to the structure of log equations. If I give you log base 2 of x minus 3 equals log base 2 of 5, well, the structure of the equation means that this has to be equal to this. So x minus 3 has to equal 5, and x would equal 8. Think about that. If I plug in 8, 8 minus 3 is 5, then they are equivalent expressions. All right, the last one is just, we use it a lot. It makes, especially with ln, it makes expressions so much easier. So if you have a log base b of m raised to an exponent, like this one, then that exponent can actually be brought to the front and then multiplied by the log. You know, and I could give you something really interesting. I could say log base 2 of 8 squared. I certainly could say, I could evaluate that and make it log base 264, and then 2 to the 6 equals 64. Or I could make it simpler by using this, applying this property, taking that 2, bringing it to the front of the log, evaluating the log base 2 of 8, which is 3. So 2 times 3 gives me 6. All right, now, again, these are laws, these are properties that we're allowed to use. Sometimes they're going to make things easier, but to do it, we want to practice using them so you can see how it can get tricky, and we can add different pieces to it. All right, so here's what I mean. Let's try and expand. Just an example of how to expand. All right, so I see that I've got 3 times x. So multiplication, we expand using addition. So I would rewrite this as log base 6 of 3 plus log base 6 of x. All right? Division, I expand with subtraction. So log base 2 of x minus log base 2 of 5. If you can evaluate any of those, you do. If you can't, you leave it alone. All right, this next one, I've got a couple things going on. I have 4 being multiplied to x squared, and I have an exponent. So I can use two properties. I can do log base, log 4. Remember, it's a common log. The base is 10. So log 4 plus 2 log x. I did that in one step. It was really log 4 plus log x squared, and then I used that property where I could bring that square into the front. All right, you're going to do D, E, and F. I'm going to go over condensing, bringing them together. So if I've got 2 logs, same base, being added, I can condense them using multiplication. So log base 5 of 6. Got to be careful when things, I have multiple logs together to condense them. I can do, let's see, what would this be? This would be log base 18 divided by 2. Be careful, this does not mean log base 18 divided by log 2. That's actually something completely different, so you want to make sure you understand that. All right, this next one, I'm going to not only, and I switched to ln here. Oh, there's that ln. See, and it looks like the word in. Be careful. Remember, it means the natural log. So I can bring that 1/2 up. That's going to be ln 25 to the 1/2 minus ln 2. 25 to the 1/2 is the square root of 25, which is 5. Oops, so ln 2. So ln 5 minus ln 2, which means ln 5 over 2. Okay? All right, I want you to try the next couple examples, C and D. We'll go over them in class, see if you got it. All right, the last thing you can do with these properties that I want to review today is, approximating values using possible values for logs. So if I give you log base 3 is approximately 0.477 and log base 4 is approximately 602, well, you can use what we're learning about logs to help us here. So if I look at this log, it's division, so I can rewrite it as subtraction. And so then log base 3 we know is 0.477 and log base 4 is 0.602. All right, I'm going to do that on my calculator. Let's see. 0.477 minus 0.602. So negative 0.125. Log 12. 12 can be rewritten as 4 times 3. So it would be log 4 plus log 3. So 0.602 plus 0.477. All right, I'll let you add those because I don't have my calculator with me. Actually, I could do that, can I? Let's see, 9, 7, so 1.079. All right, and that is how you can use the properties to make expressions a little bit easier and to actually use substitution and put values in for logs. All right, guys, hopefully that was helpful. Have a great day.